So I'm here to talk to you about an example of the normal distribution. And so what I have here set up is a chart which will demonstrate all the probabilities of baby weights. So we're going to have an average baby weight at birth of 7.5 pounds with a standard deviation of 1.25. So what that means, and so knowing that information, because it's like a naturally occurring thing, what happens with the normal distribution is that the mean is in the middle, 7.5, and what the heights of this distribution mean is that if you're between two of these sections, the area that's under that curve is the percentage of babies that are born in there. And so the 7.5 average right in the middle, so you can kind of imagine that half the babies are born before 7.5 and half below 7 after 7.5, or over 7.5 pounds. So what the 1.25 gives you really an idea of probabilities. And so if we count 1.25 above 7.5 and said 8.75, and 1.25 below, and so say that's 6.25, what the normal distribution means, and the reason why it's called a normal, is because naturally occurring things, if you have a mean and a standard deviation, we know that 68% of the data lies between 6.25 and 8.75. That's what a standard deviation means. So we know that 68% of babies are born between 6.25 pounds and 8.75 pounds. The other neat thing, and so that's a known number. We can get more accurate than that to find out what percentile babies are born in as well. But if we know it's normally distributed, we know, and we have the mean and the standard deviation, we know 68% of babies are born between those two weights. The other thing we know is that 95%, if we go one more, so we'll say at 10.00 and at 5.00, 95% of babies are born between those two weights. So we get things like, if you're born at 10 pounds, then that baby has a larger mass than 95% plus another 2.5% of the babies that are born, so 97.5%. We also know if we go one more, there's another magic number, 11.25, and so we'll say 3.75. That means that 99.7% of babies are born between 3.75 and 11.25. That doesn't seem so exciting. It kind of makes sense that that's like really light and that's really heavy. But anything that's normally distributed with a mean and a standard deviation, we can say these three numbers if we draw this little curve. The other neat thing about this is an extension. These are some probabilities we know, so that between 6.25 and 8.75 we have 68%. We can also find out what percent is between 8.75 and 10, or what percent is bigger than 10, or what percent is bigger than 8.75. We can find out all of these things just by knowing these three numbers. And so that's the magic of the normal distribution. It goes even further because we actually know what percentage is between every single dash. And that's for another time to explain that, but that's what we call normalizing data, or creating Z-scores. These Z-scores, for now, what a Z-score really is one standard deviation above, one standard deviation below, two standard deviations above, two standard deviations below, three above, and three below. And that's just kind of start talking about Z-scores, but we can talk about that another time.